So, we will come back to that your what you call that another problem, right. So, it is you have to find out that equivalent resistance R A B, some circuit is given, you find out. So, previously we have solved the star delta transformation, this we have seen in just now, right. So, let us find out that what will be first. Let me mark it by pen, right. So, you have this terminal, that terminal A and terminal B, you have to find out the what is R A B. R A B is equal to what for this circuit. Now, this is the problem. Before going to the problem, look, the C and D, it is connected by a wire. That means C and D, basically this is a common point, because no electrical element is connected here. That means similarly, if C and D is a common element, then in the circuit I will show you, that means this 5 ohm and 20 ohm, they will be in parallel. Similarly, 6 ohm and 3 ohm, they are also in parallel, and this your A to E, it will be taken out with 10 ohm, and your B to F, it is 8 ohm. So, if we draw that equivalent circuit of this circuit, if we try to make the equivalent circuit of this one, first let me clean it, right. Then it will be your something like this. Look at that A to E actually 10 ohm, that A to E it is 10 ohm, right. Here it is 10 ohm, and B to F 8 ohm, B to F it is 8 ohm. Now, C and D, it is a short circuit, C and D, it is a short circuit, it is a common terminal, because C and D connected like this. Basically if you make the, just for your understanding, if you make the circuit like this, it is this, suppose this A I am taking out, suppose this is my A and this is your 10 ohm, that is AE, say this point is your E and this point is say A, and this is your 10 ohm, right. And C and D, this is actually short circuit point, because C and D it is a common actually. I mean, we can make it like this. So, this C and D is a common terminal. So, if you make it, that means your this point is E, that means this is actually, this is say 5 ohm, right, that is E to C, and similarly E to D, this is your what you call, it is 20 ohm. So, this is actually common point C to D, this is a common point. Similarly, I am making it here. Similarly, your C to F, that is your, if this point is F, say C to F, this is your say 6 ohm, and similarly this one, if you take this is your 3 ohm, right, this is 3 ohm, and this point is A, and this, then another thing is that this point, this point is B, and your B to F, this point is your say F point, right. Well, this is C D, this is F point. So, this is your 8 ohm, right. So, this is actually series parallel combination of the circuit. So, this circuit actually, the whole circuit actually I have drawn in the your next page. So, let me clean it. So, that is why this I have made it A to E 10 ohm, then 5 and 20 are in parallel, C D is common point, 6 ohm, 3 ohm are in parallel, and 8 ohm. This is that your what you call that equivalent circuit. So, find out the equivalent one R A B. So, you have to find out your R A B, that means this point, right, that means this you have to find out from here what is your R A B, right. So, 5 and 20 are in parallel. So, this 10 ohm is in series. So, this 10, then 5 and 20 are in parallel. So, this part is 5 into 20 by 5 plus 20 equivalent, plus this part 6 into 3 upon 6 plus 3, this part plus 8, this part, right, and total then equivalent R A B is equal to 24 ohm. I mean, if you simplify, it will be 24 ohm. So, this is the answer for this problem. It is a simple problem. Only thing is that, let me clear it. Only thing is that if you look at the problem, that you have to see that this C and D actually it is short circuit, it is actually bunched together. It is a common point, because no other your electrical elements are there, right. So, that is why the answer is 24 ohm. Now, next problem. Here you have to find out the resistance between points A and D in this figure. That means right, this is your point A and this is your point D. You have to find out what is the equivalent resistance R A D, right. That is the, I mean, you have to find out the equivalent resistance, that is your R A D, right. So, that has been asked in the problem. So, let me clean it. So, now in this case what you can do is, look, if you take here that triangle BCD, that is your this thing. If you see, just hold on, if you see triangle BCD, that means B, C and D, right, and all are 20 ohm resistance. This is 20, this is 20, all are 20 ohm resistance, right. So you have to find this BCD, it is a delta delta formation, it is there, you have to convert it to star first, right, and all are equal 20, 20, 20. So things are simple. So first let me clean it. So if you make star, then it will be like this, it will be like this, and it will be like this. So all are equal. So this part and this part, you have to first find it out, that how it will be. That means as soon as you will make this one will not be there, this one will not be there, and this one will be not be there. That means whatever will come here, that will be in series with 20 ohm. Whatever will come here, 10 and 20, that will be in series 10 ohm, and whatever will come here, that will be in series with that, and whatever will come here, that with 10 ohm, it will be in series with that, right. So let me clean it, right. So if we do so, so this is that delta star transformation, actually every branch it is coming 20 by 3, 20 by 3, 20 by 3. So this is also 20 by 3, this is also 20 by 3, this is also 20 by 3. You have to find out the equivalent resistance across here. It is, you have to find out RAD is equal to how much, right. So this if you look into that, this 10 and 20 by 3, they are actually in your what you call series. So 10 plus 20 by 3, it is 50 by 3 ohm, here it is, right. Similarly here also 10 and 20 by 3, that is also 50 by 3 ohm, and this terminal and your what you call this terminal, it is a across this here also 10 your 10 plus 20 by 3, this side 50 by 3, and this side they are connected across the same terminal. That means these two are in parallel, right. And then your what you call, you have to find out that your resistance RAD across RAD. So it cannot be in series here. If you don't find, just hold on, I am cleaning it, just hold on, right. If you don't try to find out resistance here, I mean if it is asked for RAD, that is why this, when you convert it to star, when you convert it to star, right, like this. So if D point, if it is asked for something else, then this one will be in series, but as RAD we have to find it out. So naturally your this 20 by 3, it will be taken in different way, because our objective is we have to find out what is your RAD, right. So let me clean it. So when I was telling it, that I told it is in series, because but our objective is RAD. Had it been something else except this point, then it should have been in series anyway. So here it is 20 by 3, and we have to find out RAD. So ultimately what will happen, that these two are in parallel, 50 by 3, 50 by 3. So its equivalent actually will become 25 by 3. These two are parallel. So it is R1 R2 upon R1 plus R2. If you do this, this will be actually 25 by 3 ohm, right. And with that, this 20 by 3 ohm will be in series. That means if you draw the equivalent circuit further of this one, so it will be your, it looks like this, this is your D point and this is your A point, right. So this will be your 25 by 3 ohm, and this one also 20 by 3 ohm, and this is your 20 ohm. So if you make 20, these two are in series, 25 by 3 and 25 by 20 by 3. So if you add 25 by 3 plus 20 by 3, that is actually 45 by 3. So it is coming actually 15 ohm, right. So that's why this that means this 15 ohm and 20 ohm now are in parallel. So let me clean it, right. So this 15 and 20 ohm are in parallel, these two, and it is equivalent. You find out that 15 into 20 upon 15 plus 20. So RAD will be 8.57 ohm. This is your answer, right. So with this, look, for each chapter we are solving, I think this one problem number 25. So So, each chapter for varieties of circuit we are trying to solve such that it will be that your concept will be completely clear. I mean varieties of problem, so you will be knowing how to solve this one, right. Now, few exercise I am giving you that you will do it. After that we will go to the next topic. So, this is your exercise 2, problem 1, that circuits is shown, you have to find out V2. So, what is your one dependent current source is there and this is your V2, you have to find out V2, answer is given, answer everywhere answer is given here, right. Next problem you will solve, find the voltages V1 and V4 in this figure, right. You have to find out V1 and V4, right. A simple series circuit is given. So, answer is given, answer is here, answer is given. Then next problem, that your in this case it is your what you call your series parallel circuit, 2 loops are there, right. You have to find out that Vx, Is and I3, right. This voltage is Vx, this voltage is Vx, right, and this is your Is, and by voltage source, independent voltage source is there 100 volt, right, and you have to find out Vx, Is and I3. So, I3 is here flowing through the 60 ohm resistance, answer is given 25 volt, 1.25 ampere and 0.417 ampere. So, answers are given, but if you find during solving any error or anything, you just let me know, then I can rectify myself. I hope all these things are correct, but still. Then problem 4, in the circuit you have to find out equivalent resistance RAB. So, this is your A and this is your B. From here you have to find out RAB, right, equivalent. This thing, only thing is that this node and this node is a common node. Just when you will solve this one, just for this thing, this is an wire connected, this is actually common node, right. So, accordingly you will solve it, and this 6 ohm 14 ohm are in series. So, accordingly you will solve it. So, I am cleaning it. So, this is your answer is given, answer is your 27 ohm, and also given power delivered by the source, that means that 144 volt source is there, how much power is being delivered. So, here it is 760 watt 68 watt answer, right. Then this one, that in this another problem, I will every chapter I will try to give you some 5 to 10 problems, that in this circuit switch AC is open, right. The voltage divider is operating at no load when the switch is closed. The divider is said to be loaded. So, calculate A, the no load value of V0, B, load value of V0, and C, ratio of V0 by 25 at V0 by 25 at no load, and D, ratio of V0 by 25 under load. Then when it was open it is no load, and when it is closed it is load. So, it is a voltage divider circuit, a 25 volt source is there. So, please this is a simple one. So, please solve it. So, answer is given 20 volt 15 volt, another ratio is 0.80 0.60, answer is given. Next problem is determine the equivalent resistance at the terminals of the circuit. 4 circuits are given, one is 2.61 A, another is 2.61 B, another is 2.61 C, another is 2.61 D. This is for the practice, 4 problems are given. This is for first problem, this circuit is for the second problem, this circuit is for the third problem, and all answers A, B, C, D are given, all answers A, B, 4 problems are there A, B, C, D. So, these are given, and this is the fourth problem. So, all the 4th answers are given, right. Last problem answer is 33.33 ohm. So, all answers are given. So, this one you have to find, this circuit you have to find out V and I, right. So, this is the current I, right, and you have to find out this voltage, or what you call your this voltage is given, that V, right. So, you have to and voltage across this 10 ohm resistance, it is 20 volt, right. So, just for your this thing, there should not be any confusion. This voltage across this 10 ohm resistance is given 20 volt. You have to find out V, you have to find out I. Answer is given. For V it is 39.5 volt and current is 0.5 ampere. So, right, and then one more here in this figure, the first one you have to find out the equivalent resistance offered by the network to the voltage source and the current I drawn from the source. So, that means you have to find out your what you call that RAB, you have to find out the RAB, that is your what you call that resistance offered by the voltage source. It is given equivalent resistance offered by the network, sorry, to the voltage source, and the current I drawn from the voltage source. So, you have to find out basically here RAB. So, equivalent is how much, right, and here answer is given 2.5 ohm and 16 your what you call that your 16 ampere. So, similarly, here also here it is some kind of star delta formation is given. You have to determine R and I if the current through R is 0. That means capital R, that means you have to find out the capital R. This is capital R and this is small r, that determine R and I, and this is the current I, this is the current I and this is the capital R. You have to find out if the current through R is 0, that small r, if the current through small r is 0, if current flowing through this, if current flowing through this is 0, right. You have to answer is given, R is 8 ohm and I is equal to 0.8 ampere. So, you have to solve, this is an exercise. The last one more, right, one more. What is the resistance across the terminal AB of the network shown in figure? Also calculate the voltage across the terminal AC if a 36 volt battery is connected across the terminal AB. Read carefully and you have to find out what is RAB and what is VAC. Answer is given 4 ohm and VAC is equal to 18 volt. So, this 10 problem, in fact many are there, maybe many more are there, but I have given you this 10 problem as an exercise. With this this chapter is closed. Next we will go for methods for circuit analysis, right. So, next is your methods of circuit analysis. So far whatever we have your analyze relative simple circuit by applying Kirchhoff's laws in combination with Ohm's law, right. So, KCL, KVL in combination with the Ohm's law. This approach can be used for all circuit, but as they become more complicated actually and involve more elements, this direct method become very cumbersome. Just KCL, KVL and Ohm's law, sometimes it will be your little bit cumbersome. So, in this chapter we will apply these laws to develop two powerful techniques that aid in the analysis of the complex circuit structure, right. Just hold on. So, in this case first thing is the nodal analysis. So, it is based on your what you call a systematic application of KCL, and mesh analysis, it is systematic analysis of KVL. So, KCL and KVL and using this, of course, we have to use Ohm's law, of course, require every time, right. So, using these two techniques we can analyze any linear circuit by obtaining a set of simultaneous equations that are then solved to obtain the required values of the current or voltage. So, Cramer's rule is used for solving simultaneous equations which allows to calculate circuit your variables as a quotient, right, of determinants. So, we will see little bit of Cramer's rule also. So, first thing is the nodal analysis. So, nodal analysis actually is a very powerful tool for circuit solving circuit. Later we will see the difference between nodal and mesh analysis and where we can go for nodal analysis and which type of circuit will go for mesh analysis, that will be seen later. So, nodal analysis gives a general technique for analyzing circuit using the node voltages as the circuit variables. In this section we will assume that circuits do not contain voltage sources. First what we will do? First we will assume that circuits do not contain your voltage source, right. There is no voltage source we will assume, right. So, the circuit that contains the voltage source we will discuss in the next section, right. So, that is why first we will consider a circuit without voltage source, but current source may be there, but no voltage source, right. So, our interest is to find the node voltages. Now, consider just in general, you consider a circuit, just hold on, consider a circuit, right, with n nodes, you consider a circuit with n nodes without voltage sources, right. So, now nodal voltage analysis of a circuit involves the following 3 steps. First thing is select one node as the reference node, that is called datum node. You have to select one node as a reference node, and the potential of the reference node we will take it as a 0 unless and until it is specified, we will take it as a 0, right. So, what will happen? You take one node as a reference node. So, you have to assign voltages to the remaining n minus 1 nodes. I mean rest, suppose you have n nodes, one node is reference node. So, assign the voltage for the rest n minus 1 nodes by say V1, V2 up to Vn minus 1, because one node is a reference node. So, the voltages are reference with respect to the reference node, right. So, this is step 1. Next is, just hold on, let me clean it. Now, next is that your apply KCL to each of the n minus 1 non reference node. That means, you have to apply KCL to each of the n minus 1 non reference node, right. So, express the branch current in terms of, you have to express the branch current in terms of node voltages by using Ohm's law. This is the second step, and third step you have to solve the simultaneous equations to obtain the unknown node voltages. You will get those equations in terms of node voltages, then you have to solve this one. So, this is actually node voltage analysis without any voltage source. So, let me clean it, right. So, first step in the nodal analysis is the select a reference node or datum node. Sometimes we call it is a reference node or datum node. The reference node is assumed to have 0 potential and is commonly known as a ground. So, this is ground, reference node is a ground node, right. So, reference node is indicated by any of the 3 symbols. I will show you the figure as shown in figure 3.1, right. So, just let me clean it. So, if you look into that, the 3 symbols, right, the type of ground is shown in figure 3.1a is known as chassis ground and is used devices where there are chassis, case or enclosure act as a reference point, right. So, this is one symbol for the your reference node, right. Just let me clean it. Similarly, right. Similarly, common ground, that B and C also maybe is a common ground point, right. Suppose circuit when the potential of the earth is used as reference, I mean these two symbol, this is for your grounding for chassis, case or body of the your devices, something like this. So, this symbol will be used, and if the earth or your ground is a your what you call reference point, then either this symbol or either of this symbol can be used, right. So, let me clean it. So, this B and C it is common, right. So, that is why your what you call the earth ground is shown in figure 3.1b or 3.1c. So, this is earth ground B or C, right. So, this is actually symbol we will use. After selecting a reference node, assign voltage your designation to non reference node. For example, just hold on, let me move it little bit up, just hold on. So, now take for example this one, right. So, this circuit first. Now, here we have 2 current sources, one current source is here, another current source is here, right, and 2 resistors are there, R1 3 resistors are there, R1, R2 and R3, and here it is marked as a voltage V1, right, and here it is marked as a voltage V2, and this is your reference point, this is actually VO, this is a reference node or datum node, and potential of this is always is equal to 0 volt, right. This is the first thing, unless and until it is mentioned, then V0 is equal to generally taken as a 0 volt, and this is 2 nodes are given 1 and 2, right. So, this voltage actually V1 is given. So, at a nodal analysis actually this voltage V1 means this is node 1, that means this voltage actually it is your V1, right. Similarly, this voltage is your V2, that means this node voltage actually it is in V2, right, with respect to your what you call that reference node. So, and this is your this potential is 0. So, V0 is 0. So, that means here this voltage actually it is V0 is equal to 0, which I have written here, right. So, that means this voltage this node voltage is V1, this node voltage is V2 instead of writing V1 and V2. So, let me clear it, right. So, if we that means reference voltage here marked as 0 and node 1 and 2 are assigned voltages V1 and V2 respectively. Therefore, if you look into that a node voltage is defined as the voltage rise from the reference node to a non-reference node, right. So, it is a node voltage defined as the voltage rise from the reference node to a non-reference node. Now, the second step in the nodal analysis is to apply KCL to each non-reference node. Just hold on, let me clean it. Right. Second step is that you apply each node the KCL. So, that means at node 1 you have to apply KCL and node 2 you have to apply KCL. So, you have to mark some current and what current is flowing. Just before moving to that, this 10 ampere current, actually this 10 ampere current is a current source entering into your this node 1. Similarly, that 6 ampere current, it is entering at your node 2, right, this node 2. That means this 6 ampere current is leaving your this node 1 to this side, and suppose if I have that this is another direction of the current or what you call, say something like I 1, I might have taken something as later, suppose this is my I 2, right, and this current say through R 3, this current is say it is I 3, right. So, 3 currents we are marking. So, if you apply your what you call KCL at node 1, then you will get your, just apply node 1, then you will get that, look, only outgoing current is, just I am writing outgoing current is your incoming current is 10 ampere. So, here I am writing 10, right, is equal to that this current is also leaving this terminal is equal to 6 plus this current is I 2, right, plus this current is your I 1. This is at KCL if you apply at node 1. So, 10 is equal to your 6 plus, because all are outgoing, plus I 2 plus I 1. This is one equation. Similarly, if you apply KCL here, then this current is incoming, it is 6, right, just I am writing this I 2 current also coming to this node 2. So, it will be plus I 2, and this current leaving the terminal, it is your I 3, right, because I 3 is the current leaving this terminal. So, right, this is nothing but your that KCL equations you are applying. Now, if you try to find out that what will be your I 1, I 2 and this thing. So, first let me clean it, then I will go to this. First let me clean it, right. So, if you see this circuit here, now this voltage here it is marked. So, it is I 1, I 2, I 3 all are marked, all the equations all the equations I wrote for you for I 1, I 2, I 3. Now, question is that what is I 1? This voltage is V 0 is equal to 0. This is your datum node, this is datum node. That means your I 1 will be, look, I 1 will be is equal to V 1, it is going this direction, V 1 minus 0 by R 1, that is actually V 1 upon R 1, right. Similarly, your if you look into I 3, I 3 is equal to I 2, I will come later, this is I 2, I will come later. I 3 also will be V 2 minus 0, because datum node voltage is 0, not writing V 0 again and again, directly writing V 2 minus 0 divided by R 3, that is actually is equal to V 2 by R 3, right. And I 2 is equal to, writing here, I 2 is equal to, it is this voltage is V 1, this voltage is V 2, and current actually flowing from your node 1 to node 2, I 2 actually node 1 to node 2. That means, if you write like this, I 2, I 1 2 is equal to I 2, that means I 1 2 means current flowing from node 1 to node 2. So, it will be your V 1 minus V 2, this is V 1, this is V 2, V 1 minus V 2, resistance is R 2, V 1 minus V 2 by R 2, right, this is actually V 2, right, V 1 minus V 2 upon R 2. This way all, that means all the KCL equation I have written, after they replace I's by all the V's. So, you will get the equation for the voltage, simultaneous equation you will get. So, let me clean it. Hope these things are understandable to you, not a difficult one, a very simple one, and you can easily solve it. And after that we will solve several varieties of problem, I mean all possible types of problem, such that you will have actually no problem for solving this thing, because this course that mostly it will come, I mean there a lot of your what you call mathematical, so I mean all the mathematics will come, a simple mathematics for solving this circuit analysis both, and whatever you are learning now in DC, same philosophy will be applied to AC, right. So, at that time you will find things are very simple. So, anyway, So, if you write down now equation this one, I mean KCL, what I wrote initially, that 10 is equal to 6 plus I1, 6 plus I1 plus I2. At the beginning I showed you all this, and I wrote also for you, and at note 2 it is 6 plus I2 is equal to I3, right, and all the expression for I1, I2, I3 I wrote for you, right. So, again from the circuit only I have to explain everything. Now, again all these things are written here, that if you look into that, whatever I said, it is written for I1 is equal to V1 upon R1, equation numbers marked, right. Similarly, I2 also I wrote for you, right, it is V1 minus V2 over I2 means that it is in that branch 2 current flowing from node 1 to node 2. You will go back to the circuit, or already I have told you V1 minus V2 upon R2, and I3 also I told you V2 minus 0 upon R3. So, V2 upon R3. So, all this I1, I2, I3, this all this expression, let me clean it, all this expression you just put in these two equations, that is equation is chapter 3. So, 3.1 and 3.2, you will that all i's should be replaced by this equation. So, it will be equations of V1 and V2, right, linear equations. So, basically if you put it, so it will be and simplify it, you will find that your substituting equation 3.3 and 3.4 into equation 3.1, it will result this equation 1 upon R1 plus 1 upon R2 into V1 minus 1 upon R2 into V2 is equal to 4. So, this is one equation. Similarly, substituting equation 3.4 and 3.5, right, in equation 3.2 you will get 6 plus V1 minus V2 upon R2 is equal to V2 upon R3. Now, you simplify, you will get minus 1 upon R2 V1 plus 1 upon R2 plus 1 upon R3 into V2 is equal to 6. So, basically this equation is function of V1 and V2, and this also function of V1 and V2. So, you can easily solve equation 3.6, right, and your what you call equation 3.7 for V1 and V2, but here parameters at present not given. Later when we will take the numericals, we will take different parameter, different examples, right. So, in this case if you solve it and put it in a all these things are written here, these are all simples, no need to clarify again whatever I said, right. So, this circuit actually you have a 3, I mean if you look in the circuit, you have a basically you have this one node, this is node 2, and this is your datum node O, right. So, this is basically V0 is equal to 0. So, basically you have, so n is equal to 3. So, for you have n minus 1 number of equations, simultaneous equation for solving, because this voltage reference voltage is 0. So, that means you have n minus 1 is equal to 3 minus 1 is equal to 2. That means you will have 2 equations and 2 unknown. So, V1 and V2 2 equations, and we have got 2 unknowns, right. So, thank you very much. We will be back again.